Hello, welcome to yet another episode where we shall be looking at the preparation for the end of year mathematics, paper one for the grade sevens. Okay, so before we start, we basically need to know what contents are going to be in paper one, because at the end of the year, we're going to have two papers. There's going to be a paper one, and then there's also going to be a paper two. So with paper one, just to make life easy for ourselves, we're going to have term one and term two's work. Okay, so term one and term two is paper one for grade sevens. And then term three and term four's work is what is normally tested for paper two. So what topics are under, let's say, paper one? What did we do in term one? And so in term one, you might have looked at something called whole numbers. Okay, let me say whole numbers. And then under the whole numbers, there are different aspects like different types of numbers or properties of numbers. Okay, talking about the whole numbers, the natural numbers, the integers, and how they operate. And then two, you also talked about the different calculation techniques whereby you use the bed mass, or some people call it the bod mass. Okay, those are calculation techniques to see the priority of the symbols. The next, you have the multiples and factors. Okay, those are still under whole numbers. And then you also have, let's say, what we call the financial maths. Okay, in this case, you'll be talking about the interest and the budgets, the accounts, the loans, the profit, the loss, all those things compounded together. Okay, so that is topic number one, whole numbers. And topic number two is what we call the common fractions. Okay, I'll say common and then decimal fractions, because it's just one and the same thing, okay? Common and decimal fractions. Then under the common fractions, you need to know how to illustrate, how to do the addition, the subtraction, the multiplication, and then the division, okay, of these fractions, the decimals as well as the common fractions. You also need to know how to do the conversion. Let's say moving from a common fraction to a decimal, and then moving from a decimal to a common, and then we can also bring in an aspect called the percentages, okay, in this thing. And then besides that, we also have what we call the equivalent forms, okay, equivalent fractions, meaning that fractions that are equal in value, but having different numbers. Then after the decimal fractions, the third topic in paper one is what we call the exponents. Okay, exponents. We know that we have different laws of exponents. Okay, the laws of exponents, and then how to compare the exponents. Okay, someone can tell you this is 2 squared, and then this is maybe, I can say 2 to the exponent of 0. We use this, that, or the equal sign, and then you need to tell us what exactly is happening there. Then besides the exponents, topic number 4 under paper 1 is what we call the integers, the positive and negative numbers, know how to compare them, know how to do calculations with them. How do you add, how do you subtract, what happens when both signs are negative, being multiplied together, or both signs are positive, or a negative and a positive, we shall see that. Then topic number 5, we have what we call the numeric and the geometric patterns. Okay, some people call it just number patterns. Know how to extend the patterns, how to get the rules, and then if sometimes we use the geometric aspect, just know how to draw the shapes, okay, that follow in the pattern. And then lastly, we have our functions. Okay, functions and relationships. So what this entails is basically the different relationship between numbers. So in grade 7, we normally talk about the number sentences. Okay, and then you need to know how to draw the table, the flow diagrams, or the spider webs, and then how to get the rules or the equations, basically. Okay, so those will be the topics of paper 1. We shall go over the topics of paper 2 when we are using, or when are going over paper 2 as a revision. So I'm going to use this paper, okay, a final paper for November 2025, just to prepare ourselves. Okay, it's not a paper that is coming, but we can use it just for revision purposes. So it's a 50-mark paper for 1 hour. So we need to also train ourselves how to manage the time that we are given. Some people will give you 1 hour, others will give you 1.5 hours, depending on it. So we need to read the questions carefully, answer all the questions in the spaces. All calculations must be shown on the paper. You are not allowed to use a calculator. Okay, so we shall try not to use a calculator. Okay, so question number 1, which is the first part, 1.1, arrange the following numbers in descending order. So this is part of the whole numbers. So when you talk about descending order, it's basically an order where you start from the big to the smallest. Okay, so the biggest number to the smallest. When you look at all these numbers, they're in millions. Okay, so since they're all in millions, let me start by looking at the first digit. So they all start with 7s. Okay, we have a 7, there's a 7, and then there's a 7. Then let me look at the next digit. This is 4. This is 7. This is 8. This is 5. And this is a 1. So meaning that 789766901 becomes the biggest number. Okay, so we're saying this is number 1. Then we have 77 is going to be number 2. And then we have 75 is going to be a number 3. 74 is going to be a number 4. And then this will be our last number. So we say 779, 766, 988. Number 3, we say is a 759, 766, 899. And number 4, we have 749, 766, 998. And then lastly, we have our 719, 766, 990. Okay, so that is 1 mark. Then 1.2, list the first 4 prime numbers. So we know that prime numbers are basically numbers that have 2 factors, okay? That is 1 and itself, okay? So the number that we're talking about. Alternatively, we're looking for numbers that can only be divided by themselves and 1. There's no other number that divides them. So the first prime number is a 2, okay? The next prime number is a 3, followed by a 5, followed by a 7. So those are the first 4 prime numbers. Now remember, 1 is not a prime number, and then 1 is not a composite number. Okay, so 1 does not fall between the 2. Then 1.3, calculate the product of 3198 and 715. Now in this case, you have all choices to use whichever method you feel comfortable with. Okay, some people would prefer to use the Pison's square method. I would prefer to use the column method for as long as the target is to get to the answer. Okay, so I'm going to use the column method and see. So 3, 1, 9, and 8. Then I will write the 750 based on the place values of these numbers. Then we say in times. Okay, so we're going to start with a 0 as we multiply all these numbers by everything there. Some others can do it using the expansion. Okay, so 0 times 8 is a 0. 0 times 9 is a 0. 0 and 1 is a 0. 0 and 3 is a 0. Okay, then I need to place a 0 under the position of the last 0 or the last digit, because this 0 is just a placeholder. Then I start with 5. 5 times 8 is 40. So I write the 0, I carry the 4. 4 times 9 is a 45 plus 4 gives me a 49. I'll write the 9, and then carry the 4. And then 1 times 5 is 5 plus 4 is a 9. And then 5 times 3 is going to be 15. So I'll write the 15 the way it is. Then I'll indicate 2 zeros again under the last 2 digits as placeholders. Then I'll start with 7 because the answer for 7 must go down below 9, below its position. So 7 times 8 is going to be a 56. I write the 6, and then I'll carry the 5. Then 7 times 9 is a 63. 63 plus 5 gives me 68. I write the 8, carry the 6. 7 times 1 is 7, plus 6 is 13. 3, we carry 1. And then 7 times 3 is 21, plus 1 is 22. So 2 with a 2, just in that particular order. The moment you mess up with the positions, then chances are high you're going to get this wrong. Then we do the addition, so that's a 0. That's a 0 because we have no number there. Then 0 plus 9 plus 6 gives me a 15. I'll carry the 1. I know that 1 plus 9 is a 10, plus 1 is 18. 8, we carry 1. 5 and 3 is 8, plus 1, that's going to be a 9. 2 and 1 is a 3, and then this is a 2. So that becomes our final answer. So you multiply, we must add up the results for each one. Okay, so that is how I would have done 1.3 for 2 marks. And then 1.4, where we have the order of operations. So we have more than one sign. So in cases where we have more than one sign, apply the BEDMAS, or sometimes people call it BODMAS. Okay, brackets of division, of multiplication, addition, and so on and so forth. So we have a bracket here. So we're going to start with this bracket before we can do anything. So I'll rewrite the 25 minus, I have 4 times. I know this is 7 plus 5 gives me a 12, divided by 4 plus a 3. Then, since the brackets are sorted, I need to go to the division part. Division is having 12 and 4. So when I say division, I look at the sign division and look at the numbers that are bordering the division. So it's going to be a 25 minus 4 times 12 divided by 4 is a 3. And then I'm adding the 3. Then division is done. We go to the multiplication. So multiplication of the numbers is 4 and 3. So 25 minus 4 times 3 gives me a 12 plus a 3. And then you can do your addition or subtraction, whichever one might come first. So let me start with the subtraction. So 25 minus 12 gives me a 13. And then a 13 plus 3, I'll end up with a 16. Alternatively, if you do your subtraction or your addition, you're going to get it. You have to pay attention to this sign. That's why I chose to start with subtraction. But in cases, okay, where you have multiplication and division, any can start. So you can start with multiplication, then divide. Okay, that's the order. So if multiplication and division have been sorted out and you have addition and subtraction, any can still start addition or subtraction for as long as there's no multiplication there. Okay, so that is 1.4. 1.5. I'm telling us that 3 friends buy a lotto tickets together. John gives 12 runs, Victoria 20 runs, and then Fazili 28 runs. They win 20,000 altogether. How should this amount be divided fairly amongst them? So the only way for the division to be fairly done, it must be done according to the ratio of what everyone contributed. So if I have the 12 runs, dot, 20 runs, dot, 28 runs. Step number one, this question is indirectly asking us to divide 20,000 in this ratio. Okay, so I don't need to simplify it. I can just use it the way it is. But if I were to simplify it, I'll divide through by 4. Okay, and then I'll have a 3. I'll have a 5. And then I'll have a 7. Okay, I'm saying this whole thing divided by 4 because I see 4 is common. Then step number 1, I'll get the total ratio, which is 3 plus 5 plus 7, which gives us what? A 15. Okay, so if that is 15, then I'll get the 20,000 that is being divided by 15. But if you still use the 12, the 20, and that, you still end up with the same answer. You get an answer of 60. And then divide 20,000 by 60, you should get somewhere there. So 20,000 divided by 15. I'm getting a very big number. So if we use our long division, it's going to be 1.3 with some remainders. Okay, I'll say 0.33. Then for Joe 1, the ratio is a 3 multiplied by 133,33 because there's a remainder of 1/3. So when I multiply that, we are getting 3.999.99, which is roughly a 4,000. Okay, maybe I should even erase this out and give it as a decimal, which is like 4,000/3. And the next we have Victoria. Victoria is 5. He's saying 5 multiplied by 4,000/3. Okay, 4,000/3. We are multiplying it by 20. That gives us, nope, something is not making sense because it's a 5. Why am I not using 20? So it's 6,000,6666666. Okay, so that is a 6,666,67. And then lastly, we had Fezile. Fezile was 28, which is a 7. So 7 times 4,000/3. When I multiply that, I'll end up with 9,33. So that's basically what we get. So if we add up all these 3 numbers, we should be able to get to the 20,000 that they gave us. Okay. Question number 2, which is the common and decimal fractions. Complete the following table. Write the fraction in its simplest form. So the decimal is this, the common fraction is that, and then what is the percentage? So the percentage, multiply this by 100. So this 100 cancels this 100, we have 9%. Then how do we move from a decimal fraction to a common fraction? Just count how many digits does the comma need to cover for it to be away from the digits or in front of the digits. So it's going to be 1 step. So if it's 1 step, then it is the same as 3/10. And then 2.2, calculate the following in the simplest form. So you have 2 ways of doing this. You can either change this into improper fractions first, or some people would prefer to subtract whole numbers separately and the fractions also separately. But there are cases where you shall get negative numbers. So let's start by changing these mixed fractions into improper. So that's going to be 8 times 5 plus 1 over 8 minus 9 times 2 plus 5 over 9. So we know that 8 times 5 is 40 plus 1. That's going to be 41 over 8. This is 18 plus 5, which is a 23 over 9. Then we can create the same denominators. I believe the examiners were kind of unfair to say no calculators, but we know grade 7s, we have to use the multiplication, long multiplication. Okay, so let's see. We need to multiply this, that, and that. That's the simplest method I normally use. I know that 41 times 9 is going to give me 369. Okay, because 9 times 1 is a 9, 9 times 4 is 36. Okay, so I'll say 369 minus, what is 23 times 8? That's a 4 and a 2. 2 times 8 is 16 plus 2 is 18, which is 184. Okay, so if that is correct, we're going to subtract 184 over 8 times 9 is 72. We simplify this, 369, take away 184. We end up with 185 over 72. Now, the question is, how many 72s can we get in 185? Okay, so we need to do the calculation and see. So 272s are going to be 144, meaning that we have two whole numbers. What is 185 minus 144? We are getting a 41. So 41 over 72. So if the question was in mixed form, even the answer needs to be a mixed form. Okay, 2.3. A magic square is a puzzle where all the rows, columns, and diagonals add up to the same total. Okay. They want us to complete the following magic square by filling in the missing fractions. Okay, so what we know is just the top part is complete, and then this side is also complete. Meaning that if we have 3 plus 6, that's going to be 9. 9 plus 2 quarters, which is going to be 11 and a quarter. Okay. And then looking at this, 3 and 6 is going to be a 9 plus 1, that is a 10. And then we're also going to have 11 and a quarter because of these two. Now, the question is, how do we work this out? You can also change this to decimals so that life is easy for you. This will be a 6.75. This is a 1.5. Okay. Then for us to get 11.25, you just have to add these two and then subtract. So this is a 1.5 plus a 5.25, which gives us a 6.75. So 11.25, we are subtracting the 6.75. What do we get? Saying minus 6.75, that gives us a 4.5. You can write it as a decimal, or you can give it as a common fraction. Okay. Same story here. This is a 6.75 and a 0.75. If you add them together, you end up with a 7.5, but we are subtracting it from 11.25. So 11.25 minus 7.5, it gives us a 3.75. Okay. That is 2.3. Then question number 3, place values. Write down the place value of the underlying digit. So we know that 1 represents units. Some people call it ones. 0 will be the tens. 6 will be the hundreds. Okay. But the first digit after the comma is known as the tenths. Okay, something like that. Since they want the place value, we just leave it like that. So tenths or 1/10 under the value. Then they want us to round off this to 1 decimal place. So when you're rounding off to 1 decimal place, meaning that we need one number after the comma. Now we have a 0. What digit comes after 0 is 8, meaning that 8 is going to add a value of 1 there. So that our answer is approximately 23,1. So digits between 5 to 9 will always add a value. Digits between 0 and 4, they add no value, or they add a 0. Question 3.3. 3 packets of sweets are costing 36 rands. What's the cost of 5 packets? So let's see, what's the cost of 1 packet? We're going to say 36 divided by 3, which gives us 12 rands. So if 1 packet is 12 rands, meaning that 5 packets are going to cost 12 times 5, which is 60 rands. All right, then question 3.4, taxi driver pays this much for 58 liters of petrol. Calculate the price of 1 liter, correct to the second decimal. Now, you see, we need to disregard the instruction that was given of no calculators. Because now when you get questions like this, they want answers in decimals. And it might take forever for a learner just to get this using long division. So what I believe, learners should use those small calculators that are not really scientific and, fancy. But let's see. So what we do, you must get, they want the price of 1 liter, meaning that we're going to get the 714,58 and then divide it by the 58 to get how much is it for 1 liter. Okay, so 714,58 divided by 58, I'm getting 12,32. Okay, so every liter is costing 12 rands and 32 cents. 3.5, a bus driver buys this much of diesel. It costs this much per liter. How much does he pay? So if 1 liter is 11.89, how about 57.83 liters? It's going to be 57.83 times 11.89. Okay. So let's see, 11.89, and then that gives us 687, we can say 60 if we are to round it off. All right, so that is that. Question number 4, simplify the following. So we have integers now. So whenever you have a square root and numbers inside, have a plus or a minus. You have to start by adding what is inside. So we know that 36 and 64 is 100. I'm just trying to rewrite everything the way it is before I simplify. So I know that the square root of 100 is 10. The cube root of 27 is a 3. 3 squared is the same as 3 times 3. What is 10 times 3? It's a 30. 3 times 3 is a 9. So 30 minus 9, we get 21. That becomes our answer. Then order the following in ascending. So ascending is from smallest to biggest, okay? So smallest to the biggest. Now, negative numbers are always small, very, very, very small. So which one is the smallest of them all? This is the smallest. The bigger the negative number, the smaller in value it is. It's going to be number 2. It's going to be position 3, position 4, 5, and 6. So we have negative 312. We have negative 113. We have negative 99. We have a 0, 291, 1320. All right, draw a number line and fill in numbers from negative 210 up to negative 201. So they want us to see where do we represent those numbers. So if this is 2, 3, 4, 5, 6, 7, 8, 9, I'll say 10. So if this is a negative 210, negative 209, negative 208, negative 207, negative 206, 205, 204, 203, 202, 201. And then you'll have negative 200 there. So this is what they wanted you to do, not the other way around. Then calculate this. So we have negative 19. If we have a plus and a minus next to each other, they neutralize to a minus. And then a plus and a minus, we get a minus. Then negative 19 minus 7. So meaning that we're moving from the negative 19, you move 7 steps again to the negative side, which is going to give us a negative 26. Now we are subtracting 4. So from negative 26, we need to move 4 steps again in the negative, which gives us a negative 13. All right, 4.5, what is the difference between the maximum temperature of this and the minimum temperature of this? Now, the word difference in maths means subtraction. Okay, so if we get the maximum minus the minimum, it's going to be 16 minus negative 9. So a negative and a negative together becomes a positive. Okay, 16 plus 9, we get 25 degrees Celsius. 4.6, in a quiz, you score 5 points for the correct answer, and then negative 3 for a wrong answer. What is your score if your answers were 4 correct, 3 wrong? So 4 times 5 plus negative 3 times 3. So 4 times 5, we have 20 points. 3 times 3, 9 points will be taken away from the total of 20, meaning that you'll have 11 points altogether. All right. Then question number 5, which is the number patterns. Table below shows a number sequence, position, and then the term. So in words, they want us to describe the rule that we can use to find a term in any position. So what are we doing? We are basically adding 3. Okay, so we can say that add 3 to the previous to obtain the next term. Okay, so that is that. Then find the nth term. So with the nth term, normally I say Tn is equal to 3n. But then what is the first number? So if I was to go backwards, so from 15 minus 3, I have a 12, minus 3, I have a 9, minus 3, I have a 6. This is position 4, 3, 2, then minus 3, I have a 3. So what's happening? It's basically 3n. Because I know that 3 times 5 is 15, 3 times 6 is 18, 3 times 7 is 21, 3 times 8 is 24. 3 minus 3, there is nothing to add there. Then write down the 10th term. So T10 is going to be 3 times 10 because 3n means a multiplication, 3 times n. So that becomes a 30. And then 5.1.4, what are the terms in the sequence called? What are the terms in the sequence called? So what do we call these terms? 3, 6, 9, 12. So these are basically multiples of 3. Okay, if I'm to look at it neatly. So those are multiples of 3. And then consider the geometric pattern. We have stage 2, we have 4 squares or 4 circles, and then we have 9. They want us to complete the table. So these are square numbers if you look at it. Okay, so 1 squared is a 1, 2 squared is a 4, 3 squared is a 9, meaning that 4 squared is going to be a 16. What gives us 144 is going to be 12. Okay, then find the number of circles in the 10th pattern. So T10 is going to be 10 times 10, which becomes 100. And then they want us to find the missing numbers. Okay, it's a flow diagram. So twice x, meaning that we are multiplying by 2. This number here multiplied by 2, we add 2. So if it's a 3 times 2 is a 6 plus 2, we're going to have 8. You're saying 3 times 2 plus 2. And then for us to get what is supposed to be here, we need to move backwards. Where there is a plus, we subtract. So negative 52 minus 2 gives us negative 54. And then divide by 2, get a negative 27. Okay. And then 24 times 2 is 48, gives us a 50. Negative 15 times 2 is a negative 30 plus 2, get a negative 28. Okay, 5.4. They want us to complete the tables using these rules. So we just substitute where there is x, we put these numbers. Okay, so for the first one, it's going to be 2 times 4 minus 8. So 2 times 4 is 8. 8 minus 8 is a 0. Then if it's a 5, it's going to be 2 times 5 minus 8. 2 times 5 is a 10, minus 8 is a 2. But you can see that these numbers are continuous. Even the pattern must also be continuous. If you try 6, 2 times 6 is a 12. 12 minus 8 is a 4. So this should be a 6. That should be 8. Then with the next one, do the same thing. But we need to first simplify this multiplication. We know that 4 times 2 is 8. So it's the same as x minus 8. Okay. So it's 4 minus 8 is going to be a negative 4. 5 minus 8 is a negative 3. 6 minus 8 is a negative 2. 7 minus 8, negative 1. 8 minus 8 is a 0. Then 5.1.2, asking us, are the two rules the same? The answer is a no. Why are the two rules different? Because you can see there's a 0 here, there's a negative 4. There's a 2 here, there's a negative 3. So we can say that the output values are different. And then 5.5, in order to pay for a soccer ball that is worth 250 rands, Tato wants to save up from the money his friends gave him for his birthday. He has already managed to save 130. He earns some extra cash for washing his father's car and puts aside 15 rands every week. They want us to develop a formula for Tato's savings. Why? After any number of weeks. So how many marks is this question? They don't even put. Okay, develop a formula for Tato's savings. So meaning that with his savings, we can say that we can have 130, which is a fixed because he already has this, plus 15 rands multiplied by the number of weeks. Why are they saying y again? It's supposed to be like x. Okay, so if he saves just 15 rands a week, then it's going to have 145 after that 1 week, and so on and so forth. Okay. So guys, that brings us to the end of this paper. Okay, I'll try to also source another paper and work it out so that we have options to use when we are preparing for paper 1. So basically that is it, and I wish you guys all the best. Let's meet in our next discussion of another paper 1. Bye-bye.